Ho 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 ho! Day 2 of the advent of code, and I already have an elf trying to trick me playing a game. Yo dog, I'm Italian, we practically invented the 3-card Monty, aka il gioco delle tre carte. Who do you think you're playing with? Let's get this done. Okay, here is the game. Now, what happens is that we are playing a series of games, all identified by their IDs. Now, we have an elf who has a pouch that contains cubes of 3 different colors, blue, red, and green. Each game is composed by sets. In the first set, the elf takes out 7 blue cubes, 4 red cubes, and 11 green cubes. In the second set, after the elf put back the previous set in the pouch, the elf extracts 2 red cubes, 2 blue cubes, 7 green cubes, so on and so forth. Now, what we have to do for part 1 is that we first need to identify what are the possible games. Some games are not possible because we actually have in the pouch 12 red cubes, 13 green cubes, and 14 blue cubes. So you can see here in this set, for example, that the elf would extract 18 blue cubes, which is not possible. So this game is not possible at all. So we first filter out all of the impossible games, and then we need to sum the IDs of all of the possible games to get the result for part 1. Okay, so here the solution for part 1. First of all, we have the amount of available cubes at our disposal defined as constants. Then we have a game struct that contains the ID of the game and the max amount of red, green, and blue cubes used for the game, because we're just interested in the set with the maximum amount of cubes for each color. RGB is a simple struct that contains RGB as an int, nothing more. Now, the first cool thing here is that we can use the embed package that we import this way here to have Go embed the input file into this variable. So we don't have to parse or read the file from the file system. Cool. So what we do is that we pass that input file as a string to part 1. Part 1 is pretty simple. It takes the input, parses the games, and then prepares a sum variable that we fill with the ID of all the possible games. The parse function, which is here, pretty much splits the file by new lines. It takes out the ID part and the game part from the string by splitting with a column space, and then parses the ID as an integer and parses the set with a supporting function called parse sets. And then, of course, appends the game and return the games. The parse sets function, again, there's some trickery here to split multiple times strings so that we kind of get into each set. And when we get into each set, we have the amount of cubes and the color of the cube. And then we just pretty much save into RGB the maximum amount of cubes of that color for that specific game. And that's part 1. Okay, for part 2, we are not interested anymore about what games are possible and what not. What we need to do is that we need to extract from each game the maximum amount of red, green, and blue cubes we use, multiply them together, and then sum these for each game. So for example, game 2, here we have 4 red in the first set, 6 red in the second set, and 3 red in the third set. So here we would have 6 multiplied by 3 green, 4 green, 4 green. So 3 times 4 times 4 blue, 4 blue, 2 blue, times 4 again. And then we would sum all of those for each game. The way we solve it is pretty simple. We parse the games again, and then we call it power because that's how they call it on the advent of code. And we just sum the multiplication of the maximum cubes for each color. And that's it. And there you have it, day 2 of the advent of code. The embed package is pretty cool, huh? Let me know if you would have done something differently, and I'll see you in the next one.